oh no, that's not happening, okay? I'm going to need the glasses. I'm going to need it to stay out there. So the ability to make that image and make it clear, okay, are very different. We have those areas like fovea centralis. We've got the area of like macula, okay? We've got our retina, but all of them working together give us the ability to make the image and have clear, sharp edges and everything to it. So the retina, this is very interesting right here. It is an outgrowth of the diencephalon, the primitive portion of the brain. Okay, from where egg and sperm met, one cell became two, two became four, and we developed those germ layers and so forth, those primitive layers. This is a part of that area. It's part of the brain. It is a very thin, transparent membrane attached to the rest of the eye at an area that we know as the optic disc, the portion where we saw the nerve exiting the eye. The anterior margin we refer to as the ora serrata. It was like that huge blanket-looking type thing behind the lens. And then on the back of that lens to the retina, that portion of the eyeball, we have the vitreous body. We're going to see that to the front of the eyeball, we had that watery liquid. To the back of it, it's vitreous. It's vitreous humor. It's a gel-like substance. What you're born with is all you get. It doesn't change. Okay? The only fluid that will wash and change and circulate and so forth is the aqueous. So to the back of the eye, you've got that fluid that's very gel-like to the back of the lens. We're going to find in that retina, I pointed it out in the picture, the macula lutea. Macula, once again, did we not hear that in the ear? I tend to let myself think of a mass, okay? Because once again, it's a patch of cells, okay, to the back. The pit that's in the middle of it is termed the fovea centralis. So in that patch of cells, the little pit gives us the ability for fine, detailed images. So retina as a whole, okay, will work to give us what we see. This area is helping give us details. Is it a sharp edge? Is it a rounded edge? Okay, it's giving us details for that image. And then the optic disc, back of that eye, where the nerve exits, okay, that area is the optic disc, and we form, with those fibers going out, the optic nerve, which is going to travel to the area of the brain that it leads to, which is which lobe? Occipital. Now, when you're looking at that structure with those optic nerves, one of the things it did, it does this number. All right, looks like it crosses over. Not every fiber crosses over. Vision is much more difficult than we realize, but at the same time, so important. So the way that we form an image, the light enters the eye, focuses on the retina, inverts it, turns it upside down, and then the pupil will help us respond to light because it will determine how much light gets to come in, and that's autonomic like we've talked about before. And based upon that cornea and the lens and their ability to refract the light, meaning as that ray comes in and the bend that it gives to that ray of light is going to help determine that image. So those optical components have to take and bend that light ray coming in to hit the retina. If those are kind of off a little bit, this is when we need help. We're going to need the glasses because we need to have that little bit of help. Usually what can happen, the image can go too far, it cannot go enough. Maybe the astigmatism is present, that sort of thing. And so what will happen with glasses, because when we look at the structure, okay, we're either going to have concave or convex, okay? And depending on which direction needs help will determine the lens that are made for the glasses. So whether concave or convex will help determine so that when the light comes through and goes into the eye, it's already been refracted by the glasses. They give that little bit of help so that we can form that image. Now, one of the things about this pupillary reflex, whether one eye is covered or not, and like this eye now being in the dark, the pupil stays the same as this one. So whatever happens to one pupil happens to the other, is how it should be. But if there's nerve damage, that can change, all right? But the pupillary reflex should be the same in both eyes, depending on, it doesn't matter which one the light is shined in. So this light that we take in, that the cells need to use, okay, to make the action potential, we have to turn the light energy into a chemical energy that we can process. So the cells that do that, these are my photoreceptor cells. They receive the light. Rods, cones. This is where your textbook will begin to get very detailed, talking about the rhodopsin, iodopsin, all that sort of stuff. These are pigments, and as we know, pigments are for color, okay? So that's why, because things happen in vision versus dark and light, okay? Like, for example, if you go from something very, very bright to a room that's very, very dark, it takes a few minutes for you to be able to adjust and be able to move around, okay? And then, in that situation, do you see the full detail of everything and all of the color and that sort of thing when you go from something really bright to the darkened room? Do you see that detail? We don't. We see, basically we see in gray. Yeah. And it's because of the processes occurring in these rods and cones, which your book's going to get into great detail. Okay, but what we do need to know, the photoreceptor cells are rods and cones. Rods we use for night vision, cones, the brighter light. their structure is the reason that I guess they got rods and cones as their name, okay? And they're going to have their outer, inner, and their cell body, and then their little synaptic vesicles that move onto nerve cells. All right?
So you know, like, when you close your eyes, like you see all these like shapes and colors and all that. How does that happen? Why does that happen?
With our eyes, because the eyes are taking in so much information, like right now, it's taking in information we're not even aware of. Like it's taking in the amount of light. It's actually taking pictures of everybody's faces that are around you. It's really cool. And when you close your eyes, because of the chemicals that are present, the bleaching, that's what they call it, the bleaching process that's occurring has to finish. And it makes you keep those little images. They usually call it the optical illusion, but really what's happening is it's waiting for the chemicals to stabilize in the rods and cones. And it makes you feel like you've got the image still like right there on the back of your eyelid. Really cool. So the synaptic vesicles, they are going to be releasing their chemicals onto the neural layer. So that is what it looks like at the back of the eye. Now the retina as a whole, that retina, when we say thin, it is thinner than a piece of paper. That's the makeup. Just doesn't seem like that could function for all those years. So here's what's going to happen. We're going to need some helper cells. And so we get them. All right? Because like I've said before, we're talking about the nervous system. Nervous system, we always have support cells. So bipolar cells, where, do you guys remember talking about the shapes of neurons? Okay, that's just kind of letting you know the shape of the neuron. That's the cell that a rod or cone will synapse upon. And then ganglion, meaning in a group, and this what looks like this huge ball structure area, okay? These are the bipolar, this is where the bipolar cells will synapse. And then helper cells, horizontal and amacrine, will help form connections. So basically, if this is my eye getting to the back, light comes in, goes back there, we get to the back of the eye, we get to synapse on, we get to pick up the light based on the rods and the cones, day or night, and then they'll synapse on bipolar cells, and they'll have little helper cells, horizontal, and those will synapse on ganglion, and these lead to my optic nerve. And then that sends it to the occipital lobe, where we begin to form our image based upon that information that just got sent in. If you were going to med school to be in optometry, this would get way more difficult. But for our purposes, that's pretty much what we need to understand. There are certain things that can go wrong because of the makeup of that retina. For example, in that structure at the back of the eye, for the retina, that area that was known as the macula, one of the things that we're seeing a lot of now is macular degeneration. Have you all heard that? I think they refer to it as ARMD, age-related macular degeneration.